Hi, my name is Peyton Gilbert, and I am going to be summarizing what happened in my Calc 2 lecture. So first we were introduced to this concept of work, and work is just the amount of effort you need to put into something in order to perform a task. And work is consisted of force times distance. And so you need to find the force first, and the force you need mass and acceleration in order to find that. And the units differ based on if you're in the metric system or the United States system. The metric system, that's measured in joules, and in the American system, it's measured in pound times foot. And so with this information, you can find, like, for example, if there's a book on the floor that weighs like 1.2 kilograms, and you needed to lift it up to a table that's 0.7 meters high, how much work does that involve? And so what you would need to do is first find the force. So you would take the weight of the book times the acceleration, and the acceleration in this case is just normal gravitational push onto the book that's on the floor. And so that constant is 9.8 meters per second squared. So you times that by 1.2 kilograms, so you find the force. And then once you find the force, you times that by the height of the table, 0.7, and then you get the work. So pretty easy concept, except sometimes f of x, so the function or the pathway, I guess, of like where the book would go, so like point A would be the floor, point B would be the top of the table. Sometimes that pathway isn't always constant. It's not always going to be like the same speed, I guess, but it is continuous. So what you want to do in order to find the work is basically take the line or the function and break it into little sections, and you can do that by finding the integral from a to b of f of x. And so with this, you can find the work of f of x when it's not constant. And then we were introduced to this concept called Hooke's law. So it's basically you have like a wall, and then a spring is connected to it, and then there's a box at the end of the spring. You would pull the box, and it would stretch the spring, and you need to find out how much work is done to stretch that spring. And you do that by taking position times the displacements, and the displacement would be like if you stretch it from 10 centimeters to 15 centimeters, the displacement would be 5 because you're moving it 5 centimeters. So K is like the starting position. And so, or it's the spring constant. The position constant, same thing. So for example, if it took 40 newtons to move a string from 10 centimeters to 15 centimeters, how much work is done to stretch the spring from 15 centimeters to 18 centimeters? So like what you would do is you would take Hooke's law, which is f of x equals kx, and you would plug the 40 into the f of x, and then you do equal k times 5, because 5 is the displacement, and we don't know what k is. So then you'll have to solve for k, and then once you get k, you use k times 3, because now the displacement is from 15 to 18, and so then you can do that and find out the work done. And then you can also use this kind of taking the integral from a to b to find the force with needing to lift a cable from the top of the building up. Or if you have like a cylinder and there's already water full, how much work would you need done to push water out? You can all use this by finding the integral of f of x. And then we were introduced to the average value of a function, which is basically, you just want to take the average value. You want to add up all the dots and have it go over n. But that's kind of a lot of work. So there's actually an easier formula to find the average value, which is the average of f equals 1 over b minus a on the integral from a to b of f of x dx. And it's a pretty simple equation to do because you literally just plug in points. For example, if you had the equation 1 plus x squared on the integral -1 to 2, you would plug in -1 in all the places a is at, you would plug in 2 to all the places b is at, and you would plug in the function into f of x, and then you just take the antiderivative or the integral and solve from there. And then finally, we were introduced to the mean value theorem, which that states if you have a function that's continuous on points A to B, then somewhere on that function, point C exists. And so if you know something is continuous, then you can find the mean value theorem and find where that point C is. And then that's all we did, and I feel pretty good about it, especially going over. Thank you.